In this lesson, we're going to have a look at least squares regression. So if we look here, we've got a few different points on our board here. And least squares just means finding a line of best fit. And it's in the form like you would have seen earlier in your school with y equals mx plus c, but instead we're looking at it slightly differently using the letters y equals ax plus b. And this is important because when we're using our calculator, it identifies a and b, and that's what we need to use to read off it. So we'll have a look at finding the line of best fit, and like we've done with our previous data, we're going to find the r value and the r squared value. So just going to pop in our values. $37, $51, and $79. All right. $59, $55, and $84. So we pop those into our calculator, and then we're going to use F1 for graph. We're going to check our settings to make sure that it is a scatter plot, and it's using the X list as list 1 and the Y list as list 2. So we can go back, and we are going to graph number 1. So on my calculator screen, you can see that we've got our different points being plotted there, and that doesn't tell us anything at the moment, but when you're asked to sketch a scatter plot, it's a good way for you to check what it will look like just using a rough sketch. Then we're going to calculate our variables, F2 for x, and here we have our data. So we have a, b, r, and r squared. So we've already talked about the r and the r squared value, but here we want to look at the equation of the line. So here we've got, like we said before, y equals mx plus c, but now we're using y equals ax plus b. And in this instance, our a value is 0.57. So y equals 0.57x plus 36.24. So although this doesn't mean a lot in this example, we're going to apply this knowledge in a new example. So here we've got the tread depth of some car tyres after travelling some distance of kilometres. So what we're going to do is we're going to enter this data into our calculator. So we'll just clear everything out. Okay, so we'll just pop the data in. So 14, 17, 24, 44. All right, so we've got our data in, and part A, which is the dependent variable. So down the bottom here, we've just got a little bit of information. The dependent variable is on the vertical axis. So remember when we have a graph like that this is the y-axis and the x-axis. So the vertical axis is always the y, which when we look at a table is going to be the bottom value. So what's the dependent variable in this example? Well, the tread depth is. On a scatter plot, graph the least squares regression line and state its equation. So here we've got all our data in our calculator. We know it's already set as a scatter plot. I'm going to graph it, and I can see my different points here, and then I'm going to calculate. Just going to check my data because it looks okay. So graph and calculate using x And here we go. So we have our values, and we are going to draw it. So here I can see that it's actually drawn in my line of best fit. Now I've got a feeling that my data might be wrong, so I'm just going to double check that. Okay, there it is. So that should be 35. All right, now I'm going to graph it again, and that looks a little bit better. So I've drawn it, and there is my line of best fit. It's asked me to state its equation. So if we come back into it, we'll be able to see that y equals negative 0.17 x plus 8.48. All right, so what it's saying is that for every 1,000 kilometers you do, so x is 1,000 kilometers, your tire is going to go down, so the tread in your tire is going to go down by 0.17 millimeters. So we could write out this equation slightly differently, which is what I like to do. Tread depth, so instead of y, we've got tread depth is equal to negative 0.17 times kilometers plus 8.48. So if I travelled 0 kilometers in here, I would know that it would be negative 0.17 times 0, which is just 0, plus 8.48. So the new tyre must have 8.48 millimeters of tread depth. If I was to look at part D, that Brock claims that his new tyres have done 50,000 kilometers, is this claim reasonable? What we can do is substitute in that 50. Remember, it's 50,000. This is in thousands up here, so just 50. 0.17 times 50 plus 8.48. If it's greater than 0, we can say that yes, it is reasonable, but remember, if it's a negative number, that means that there's nothing left on his tyres. When we look at our data and we have certain points, we have a range of points from here through to here. Anything outside of this data we can extrapolate. So we don't know if it's right, but we can make predictions based on our equation that we have. So it's really important to remember that if you're making predictions outside of your data set, that you are actually extrapolating.